All right, this is section 3.1 in your grade 9 math links. This is questions on powers. Question number 1 of the questions we're to do says, explain why it is often easier to write an expression as a power rather than repeated multiplication, and use a specific example. Well, the best example would be if I wanted to say the number 100 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hang on. Or we'll just make it 10 billion. Doesn't matter. 10 billion. In order for me to write 10 billion, I have to express it as a 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros, right? 10 billion would be a 1 with 10 zeros. However, if I wanted to write 10 billion without having to get writer's cramp, I could simply write 10 billion as a 10 to the exponent of 9. And that would be a quicker way to write the number 10 billion. And in grade 10, 11, 12, and maybe even grade 9, you learn something that's called scientific notation. And scientific notation utilizes this idea of base 10. And if I was to say, what is the distance from here to Uranus? Don't giggle. So I just looked it up. It's 2.817 billion kilometers away, Uranus. So if I wanted to write this number, I would have to write 2,817,000,000, and I would write it like this. But in scientific notation, what they do is they say 2.817 multiplied by 10 to the power of 6, or sorry, to the power of 9. And the reason why is this is an easier way to write a billion than it is to write it like this. So it's a way to make large numbers more manageable to write. Question 3 says, Pani says that when you evaluate a power with a negative base and an even exponent, this is the Dontovan experiment, you get a positive value. And when you evaluate a power with a negative base to an odd exponent, you get a negative value. Is Pani correct? The answer is yes, she is. And the reason is, if I just look at these here without having any numbers associated, a negative number times a negative number is a positive number. And a positive times a negative is a negative. Oh, that's a negative one. Come on, Mr. McDonald. And finally, a negative times a negative is a positive. And if you do this, the reason why is when you group two together, or even groupings, you will always end up with positive products regardless of what the number is. So if it's negative 3, a negative 3 times a negative 3, a grouping or a dyad will end up with a positive product. Over here, however, if you have a negative times a negative times a negative, that pair will give you a positive, but you'll always have an odd man out that's going to turn that positive value into a negative number using your integer sign rules. In question 4, it says write each expression as a power, then evaluate. So as a power, this is 7 multiplied by itself twice, which means I'm going to use an exponent of 2. And 7 squared is not 14, but rather 49. 3 multiplied by itself 3 times is a base of 3 to an exponent of 3 because you're multiplying it by itself 3 times, once, twice, 3 times, which equals in standard form 27. The next one is 8 multiplied by itself 1, 2, 3, 4, 5 times. So 8 exponent 5. Now for these types of questions, it's probably easier to use your calculator to assess it. You could do the long way, which is repeated multiplication, and get 32,768. Or you can be wise about things and use your newfound button, which is right. I got to use a scientific calculator. Hang on. Scientific calculator. And I put in my base of 8, and using this button right here, the XY button, if I press that after 8, that defines the base as 8, and then I tell the calculator I want 5 as my exponent, and you can see right up here, there's a little arrow, that's kind of raising that 5 to an exponent, and you press equals, and it gives you the same answer. And finally, the last question is 10 multiplied by itself 1, 2, 3, 4, 5, 6, 7, so 10 to the 7. And the nice thing about base 10 numbers is if you have a base 10 to an exponent, simply put down your 1, and whatever the exponent is, you add that many zeros. And then just back it up from the end Put commas after, oh, sorry, that's not where the comma goes. Oh, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, comma, 1, 2, 3, comma, and we have 10 million. If you go back just to double check and put 10 xy to a 7 exponent, it will give you 10 million as well. So simply base 10 numbers to the exponent, simply put down a 1, and whatever your exponent is, you can put that many zeros and you'll have your standard form number. Question 6 and 7 says evaluate each power. So in evaluating it, you can do one of two things. You could simply write it in repeated multiplication and then evaluate it in standard form. Write it in repeated multiplication and evaluate it in standard form. Write it in repeated multiplication and evaluate it in standard form. So 16 times 16 is 256. And if I think about 256 times 4, 24, 22, 10, I get 1,024. Now, an interesting way is this. If you think about this question again, the one power and base we know a lot about is base 2 because it's the easiest. And to show you that this power and this power are the same, if I think about breaking down each of these 4s, this 4 is really 2 times 2. And if I broke down this one, it would be 2 times 2. And this 4 would be 2 times 2. And so on and so forth. So if each 4 broke down into a 2 times 2, I'd really have 2 multiplied by itself 10 times. So the 4 to the 5th is the same value as 2 to the 10th because if I think about 4 rather than being the number 4, but rather 2 by 2, I know that 2 multiplied by itself 10 times is the same thing as 4 multiplied by itself 5 times. And likewise with this, 8 times 8 times 8. I'm not so good with my 8 times tables, but if I put 8xy cubed, it tells me it's 512. But just like I did with the last one, if I break 8 down into 2 times 2 times 2, which is 8, times 2 times 2 times 2, which is 8, times 2 times 2 times 2, which is 8. I think I get that enough there. Then 2 is multiplied by itself 9 times. So 2 to the 9th should be equal to 8 cubed, if we think of it that way, because an 8 is really 2 multiplied by itself 3 times. And if I take my calculator and go, what is 2 to the 9th? It is also 512. So if we look at the next one, 2 multiplied by itself 6 times. I could probably do this in my head. 2 times 2 is 4, 8, 16, 32, 64. Double check with a calculator. 2 to the exponent of 6 is 64. And finally, the last one is an interesting one. 1 multiplied by itself any number of times, this time 9 times, will always be in standard form 1, because regardless of how many times you multiply 1 by itself, you will always have a value of 1. Question number 8. So question number 8 is simply just complete the table that we've already worked on. So value is another way of saying standard form. So 6 times 6 times 6 is 36, and 36 times 6 is 216, so a standard form value of 216. 3 times 3 times 3 times 3 is 3 to the exponent of 4, or in standard form 81. Oh, something happened here now. What happened here? 49. Oh, I see what's going on here. My ink kind of got sidetracked here. Huh. Oh, well. 49 would be 7 squared, or as some people would like to say, 49 to the 1. In repeated multiplication, it would be 7 times 7. You could also use negative 7 in brackets squared, which would be negative 7 times negative 7. Or like I said, 49 multiplied by itself once, but we're not going to use that as an example because it doesn't really demonstrate good exponent-base relationship sense. Your next one. I don't even know what the question is. So 11 to the exponent of 2 is 11, multiplied by itself twice, standard form 121. And finally, your last, 125. 125 is 5 multiplied by itself 3 times, or 5 cubed, which would be the best answer for that particular one. I know. Question number 9 says, does 4 cubed equal 3 to the exponent of 4? Well, there's a difference between is it the same thing, is it the same, is it the same, or does it have the same value, right? Does it have the same value? Does it have the same value? So the first question, is it the same? No, it's not the same thing, because we could see that when we write it in repeated multiplication, because this would be 4 multiplied by itself 3 times, and 3 multiplied by itself 4 times is not the same thing. But however, it might have the same value. Let's check. 4 times 4 is 16, times 4 is 64, and 3 times 3 is 9, another 9 is 9, which is 81. And since 64 does not equal 81, the answer is false, or no, it's not. Question 10, evaluate each power. Negative 9 multiplied by itself twice is 81. Ding. Correct. So the next one you have to write it as the opposite of 5 times 5 times 5. And since 5 times 5 times 5 is 125, then the opposite of that will be negative 125. Correct. And the next one is negative 2 multiplied by itself 7 times. Running out of room. I'll put one more up here. 1, 2, 3, 4, 5, 6, 7. 2, 4, 8, 16, 32, 64, 128. And a negative base to an odd exponent makes it a negative value. The opposite of 8 times 8, or the opposite of 8 squared, would be negative 64. Negative 1, which is defined as the base multiplied by itself 5 times, is negative 1. And finally, this one's an interesting one. The opposite of negative 3 to the 7. So since negative 3 to the 7 is an odd base, or negative base, excuse me, to an odd exponent, if I put it into a calculator, I know my answer is going to be negative, so I'm going to put negative 3 as my base, and I define it as my base, to the exponent of 7. It says it is negative 2,187. So I'm going to put that in brackets, because this one here now comes down, and I now read this as either the opposite of negative 2,187, or I can also think of it as that negative symbol as a negative 1 if I wanted to. But either way, the opposite of negative 2,187 is going to be a positive 2,187. 12. Question 12 is a continuation of what we've been doing. So negative 3 multiplied by itself thrice would be negative 27. Negative 4 squared would be a positive 16. Negative 1 multiplied by itself 3 times is negative 1 in brackets. Cubed, without the brackets, it's wrong. Standard form, negative 1. Negative 7 squared is negative 7 multiplied by negative 7, which standard form is positive 49. And finally, negative 1,000 is negative. You can have one of two answers: negative 10 in brackets cubed, or if you wanted to, you could have negative 2 cubed, negative 10 cubed without brackets, and that would work as well. The first one in repeated multiplication would be negative 10 times negative 10 times negative 10. The second one would be the opposite of 10 times 10 times 10. Either way, you get a standard form of negative 1,000.